Okay, back for week three. What decided to do is make some big idea, so to speak, videos, and I'm going to try to break them up to keep them short so that you can index through the material that you are, again, interested in or need maybe a little bit more instruction or illustration. And so, with the big idea, again, just to kind of see, how all this stuff fits together in the big picture. And then obviously there's going to be specific videos of Alex examples to follow. So one of the things that we're going to be talking about is this idea of a discrete random variable. Remember, discrete is kind of a term used to determine distinct counting objects, principles, those sorts of things. And so here are, first of all, we define a random variable, and this is just from your textbook here. It is a variable that is, the values are determined by chance. And a discrete probability distribution can consist of the values of the random variable that can assume the corresponding, the values that the random variable can assume, and also the corresponding probabilities that go along with each of those values. And we can, construct these in various ways. Sometimes we do them theoretically, like we are here with the coin. And other times we can just use those or construct these by, lots of observations, which we'll see some examples later on. Some of the requirements are that all the probabilities have to add up to 1, and as well as all the probabilities have to be between 0 and 1, or else it theoretically wouldn't be a probability. So again, if we toss a coin 3 times, here's the sample space, right? We can essentially have 8 different outcomes, right? All 3 can be heads or tails, excuse me. First 2 can be tails, third one head, and so forth. And you see I have these listed here. And therefore, since they're all equally likely, in terms of tossing the coin, one toss isn't going to affect the outcome of the other. What we can do is kind of group these, in the following fashion, all 8 outcomes, each having a probability of 1/8, and then take a look at what these represent in terms of if X is the number of heads observed in 3 tosses. X can take on the value of 0, right? In other words, we had no heads we observed, 1, 2, and 3. Okay, and notice there are 3 different ways we can observe one head. There are 3 different ways we can observe 2 heads, right? In other words, we get heads the first 2 and tails the last one, or we alternate heads, tails, heads, and so forth. You can see again how this plays out here. And therefore, so the probability of observing 0 would be 1 out of 8. Probability of 1 would be 3 ways, or 3 out of 8. And same thing with 2 heads, and then finally 1. And you can see all the probabilities are between 0 and 1. And if you add them all up, 1/8 plus 3/8 plus 3/8 plus 1/8, you're going to get them adding up into 1. So this does satisfy the definition of a discrete random variable and a discrete probability distribution. We can also represent that graphically. Sometimes we call these probability histograms, where we plot the probability on the side, and with a bar width of 1, centered at the values of the random variable 0, 1, 2, and 3. We can also look at these probabilities as areas, which is going to be a big idea coming down, linking all this, or an overreaching idea where we have probabilities associated with areas. And so you can see that if the width is 1 and the height is 1/8, then again, we have that area being 1/8, and so forth. All right. So this is an example here. If I go on to this next slide that I have here, we are going to be talking about means and standard deviations of probability distributions. And so this is just again, coming from your textbook, we have some formulas, which I'm going to show you a way to skip the formulas. So But essentially here, to calculate the mean, we'll take a look at these since they're already written out in terms of your textbook. What we need to do is we need to sum up, and that's what this formula is, the products of, or the terms where we have the product of the random variable value times its associated probability. So in other words, I'm just going to take 3 times 2/5 plus 4 times 1/5 plus 5 times 2/5. That's what this is saying here in this summation notation, which again, I know gets a little overwhelming to the eye at times, but it's really a simple process. It can sometimes be tedious, but nonetheless, it's simple. And therefore, when we go ahead and add all these terms up, we get 4. And sometimes we refer to the mean as the expected value. And we'll take a look at that again in some specific examples coming up from Alex. But again, on average, that random variable is going to take on the value of 4. And again, on average here. We also talk about the spread or the standard deviation. And again, we're laying some groundwork for some future work that we're going to deal with here. But as far as the formula, again, we take the value of the random variable and we square it and multiply it by its associated probability. So I'm going to take the 3 squared multiplied by 2/5 plus 4 squared, or I'm sorry, 4 squared times the probability of 1/5 plus 5 squared times the probability 2/5. And then once we do that, then we subtract the mean squared. So we have to calculate that first. And therefore, this gives us the variance, okay, which would be about 0.8. We get the standard deviation, just like always. The standard deviation is just the square root of the variance. So we take the square root of 4/5 or 0.8 and get 0.89. Okay, so again, that can be somewhat tedious. One of the nice things that we can do in Staplet, you could see that, again, I just took the same example, the number of the ball, which would be X, 3, 4, or 5, put as associated probabilities. I go ahead and begin the analysis. It gives me a probability histogram here, and also the mean and standard deviation. So I don't have to use these formulas. Well, actually, you're using the formulas. It's just the computer's doing it all for you. So by putting all this in, it does all that tedious work and displays it in the summary statistics. That's in Staplet. All right, so kind of an easy way of doing that. Obviously, if you didn't see this video, you wouldn't be hearing my voice, or if you tried to go through this without it, you're going to get some, well, it's just going to take a little bit more time, I should say. Okay, and so I'm going to end this one here. This, again, just kind of highlights all the main points in terms of things that we're going to be applying later on. So I hope this video helped you here with discrete random variables, and we'll see you on the next video.